Okay. Now for this okay. For this afternoon naman, it is still all about writing Lewis structure, but this time Lewis structures for exceptions to the octet rule. Although most ng mga molecules, most of the ions, they they follow octet rule. Ibig sabihin, octet rule applies to them particularly if ang central atom ng molecule na yan is part of period 2, no, ng periodic table usually. Example, in the case of carbon, no, nitrogen, oxygen, fluorine, not with fluorine kasi fluorine can never be a central atom man if single bonded yung central atom, no? But in the case of carbon, nitrogen, oxygen, as part of period 2, di ba sila na ito yung period 1, then period 2, most of the central atoms found in the period of the periodic table, they follow the octet. Ibig sabihin, if they become the central atom, dapat 8 electrons lang talaga yung surrounding electrons. Okay? But there are mga few exceptions to the octet rule. Okay? And that usually occurs among molecules na may central atom located or found in period 3 usually. Okay? And down. Okay, down the group. Mula period 3 down to the group. Usually kapag naging central atom yan sila, okay, they usually they usually counteract ba, or they do not follow, not counteract, they do not follow the octet rule in writing Lewis structure. Kumbaga kapag naging central atom, for instance, si phosphorus, sulfur, si chlorine, bakaha, si selenium, okay, or si xenon, okay, usually dili 8 lang ang electrons nga nag-surround sa ilaha kapag naging central atom yan sila. Okay? Or pwede din naatay mga atoms nga lower than 8 electrons ang mag-surround sa ilaha. So yun yung mga exceptions. It's either more than 8 or less than 8 electrons ang surround sa ila. Pero upon writing their Lewis structure and then you try to check their formal charges, diba, with formal charges, it will help us determine kung ang atoms in that molecule are in stable binding. So upon getting their formal charges, stable naman. Okay, so yun yung mga exceptions to the octet rule in writing Lewis structure. So isa-isahin natin yun sila. So there are actually 3. Okay, 3 important exceptions occur in molecules, particularly with una, ayan, with those electron-deficient atoms. Okay? So, again ha, isa sa mga exceptions in writing, exception sa octet rule in writing Lewis structures, those molecules na may central atom nga electron-deficient atom. So, say for example, yung mga atoms, particularly gaseous molecules nga na ay central atom na beryllium at saka boron. Okay? Si beryllium and boron, in most of the gaseous molecules, kapag naging central atom yan sila, they are often considered electron deficient. Diba? Pag sinabing deficient, kulang. Okay? So mula 8 electrons ng octet, 'di ba, pag octet 8 electrons. Okay? Pag electron deficient, lower than 8 naman yung surround nga electrons in that central atom kapag beryllium and boron yung central atom. So say for example, ang molecule na given is beryllium chloride. Okay? So, kung i-try nyo, ngayon, i-draw yung Lewis structure nila in your, siguro na mo yung notes dira, you will come up with this structure. So, beryllium as the central atom, then meron siyang dalawang chlorine as the surrounding, okay, atoms. If you try to total their valence electron, di ba, pag chlorine 7 ang iyahang valence electron times 2, that would be 14. Then beryllium, pang ilan ba si beryllium? Di ba beryllium has how many? Okay, 2 lang yung valence electron niya. Okay, so nalipat pod ko. Ang pagkuha sa valence electron ha is you have to refer to the group number. Okay, group number ng, ayan. Diba sabi ko kapag A elements, kung saang group siya. Okay, kung saang group siya na belong, ayan. That would be their valence. So for beryllium, 2. Okay, nasa sa group 2, so that would be 2. Okay, kaya pala parang may mali. Okay, sige, thank you for that again, Kenna. Sige, so 16 lang, so hindi 18. Okay, so 18, total of 18, 16, sorry, ayan, 16 electrons, minus 4, so 12. So ayan, so okay na. So 12 yung remaining electrons. Then yung 12, you have to distribute that. Okay, kung titingnan mo ngayon, yung central atom na beryllium, 'di ba, 4 lang yung surrounding atoms niya. Hindi 8. 'Di ba, sabi natin 8 dapat pagkapag octet. Pero again, we are studying here those molecules na upon writing their Lewis structure, exception sila sa octet rule. Okay? So in this case, yung central atom nga beryllium, it only has 4 electrons. Now, what if, pwede ba ma'am nga i-apply namin dito yung fifth rule, fifth step in writing Lewis structure? Di ba may fifth step na kapag hindi na-attain ng central atom yung octet, kuha tayo sa surrounding. Okay, kuha tayo sa surrounding atom na lone electron, then gawing bonding pair. Well, in that case, hindi po yan applicable for beryllium. Kasi, if you recall, ang mga halogens, di ba chlorine is a halogen? Okay, so as a halogen po, any halogen, kapag surrounding sila in a Lewis structures, kapag nasa surrounding sila, they will never ever give up, okay, give a lone pair sa central atom para maging stable si central. Kasi remember, as a halogen, ang mga halogens, they are said to be highly electronegative atom. Kapag highly electronegative sila, di ba, electron rich. So sila talaga dapat yung magmamay-ari ng mga lone electrons na yan. And kung gusto nyo pang i-check yun kung stable na ba talaga yung bindings, okay, yung binding ng mga atoms in that molecule, we can use the formal charge, no? Kunin natin yung formal charge nila each. Naalala ba yung formal charge? Di ba yung formal charge is ibang kulay naman. Di ba, formal charge is equivalent to number of valence electron, then the number of unshared electrons, okay? Then add mo yung number of bonds. Okay? Yan yung formal charge. Okay, try natin kunin yung formal charge ni chlorine dito. Obviously, 0 yan. Kung imo i-compute ha, using this, compute nyo na lang sa notes nyo later on. Okay? Using that formula for the formal charge, chlorine here will get a 0 charge. Wala siyang charge. So, the same with the other chlorine. The same lang naman sila ng state. Okay? And beryllium, here, kung kukunin nyo, sige, try natin ha. Number of valence niya again is 2 minus, diba, beryllium. Okay? So, minus number of unshared. Wala naman siyang unshared. Meaning, wala siyang lone pair. Ito ha, si beryllium. Wala kayong makikitang lone electron sa kanya. Okay? Then, the number of bonds is 2. So, 2 minus 2, diba? 0. Okay? The moment nga walang charge, yung formal charge ng atom na yan in that molecule, wala, meaning, it is at its stable binding. Yan yung pinaka-stable binding talaga nila kasi walang charge. Okay? Kapag kasi naging positive, negative yan, somehow, okay din naman, pero much more preferred pa rin, di ba, yung 0. Okay? Ayan. So, meaning, at this state, si beryllium, although 4 lang yung, di ba, 4 lang yung surrounding electrons niya, hindi niya na-attain yung octet, pero stable siya. Stable siya in that state niya na dalawa lang yung bonds na na-form niya, total of 4 electrons. Okay, this is 2 electrons here, 2 electrons, so 4 electrons. Okay, the same goes with boron in the molecule of, boron trifluoride. Ayan, parehas lang yan ha. Si boron trifluoride, di ba? Group 3 ba siya? Hindi na ako memorize man. Okay, nasa group 3. Ako to i-check ha. Para sure.
Yes, ma'am.
Sige, very good. Nasa sa group 3. Okay, so it has a valence of 3. Okay, and then fluorine, the same with chlorine, so 7. Okay, so 21 for fluorine plus 3, total of 24 valence electron. So boron, so you got 4 surrounding fluorine, 24 yung na-total mo, diba? 24 yung na-total mo na valence electron, minus 6. Kasi meron ka ng 6 na present na bonds. Okay, so 24 minus 6, 18. Okay, so distribute mo yung 18. So tag-6 yung tatlong fluorine na yan. Okay, so 18 na distribute. Now, tingnan si boron. Diba? Hindi niya na-attain yung octet. Ilan lang yan? 3 bonds, so equivalent to, this time, 6 electrons. Okay? So, ganun din, electron-deficient. Kasi lower than 8. So, pasok sila doon sa electron-deficient atoms. Sila actually yung pinaka-common. Basta gani, electron-deficient atoms, central atoms na electron-deficient. Si boron usually at si beryllium yung pinaka-common na example. Okay? Sige, check natin kung at its stable binding pa rin ba si boron dito kahit 6 lang yung surrounding electrons niya. Okay, so check natin ha, formal charge. Diba? Valence electron niya, okay, 3. Okay, sige. Para makita nyo, boron, formal charge. Okay, 3 minus number of unshared. Wala naman siyang unshared. Puros man yan, bonds. So, number of bonds, 3. So, you will have, so si boron dito may 0 charge. So, the same thing with the other surrounding atoms. So, yung technique nyo lang para malaman nyo na 0 talaga yung formal charge ng atom na yan in that molecule. I-memorize nyo lang talaga yung number of stable bonds per atom na very common. Diba si hydrogen, isa. Yung mga halogen, so patsok doon si chlorine, fluorine, bromine, iodine, isa lang. Okay, isa lang din. So, automatic, huwag mo nang i-compute yung formal charge niya. Yan na yung pinaka-stable binding nila, isa. So, kapag nakakita ka ng, meron na siyang isang bond, okay, yung halogen, okay, 0 yung formal charge niyan. Okay? Si carbon, 4. Okay? Si oxygen, 2. Ano pa? Si nitrogen, 3. So, yun ha. Yan, kahit yan, i-memorize nyo yung pinaka-stable number of bonds nila. So, that's it for the first exception. Okay, kapag ang central atom, electron-deficient siya, exception siya to the octet rule. So, okay lang na yung Lewis structure niya, hindi niya na-attain yung octet. Sige. Okay, let's have the second exception, okay, to the octet. Okay, so ito naman is kapag meron kang central atom nga odd, okay, odd number. Di ba kung maingon ka og odd kay bungkig, opposite sa even. Example, sa may bungkig, 5, di ba, 3, 7, 9, nang wala isa kung mag-partner sila ba nag-iisa nga mahimong sige na, fifth wheel, third wheel, seventh wheel, sige na bitaw. So bungkig. Okay? Kaya di ba when you distribute an electron, dapat in pair sila. So dire, upon distributing the remaining electron, natay makita nga sobra na ay unpaired ba. Okay? Now, this is usually observed based on the term, no? This is usually observed sa mga molecules na naay central atom with an odd number of valence electrons. So, kung inyuhang lantawon inyuhang periodic table, di ba, naatay group 5, di ba, naatay group 7. So, nga na, usually, kanang mga atoms na nandun sa group 5, usually, okay, group 7, usually, kapag naging central atom yan sila, naay mga molecules, okay, kung saan sila yung central atom, may unpaired, no, may isang unpaired electron talaga. So, doon pasok yung odd-electron atoms. Okay? And, most commonly, most commonly encountered yun, nga stable species that usually exist with an odd number of electron is yung mga nitrogen oxides. Ito. Nitrogen oxides, kasagara gyud, no? Kung mag-search kag example ng mga sa Google ba, mag-search ka og example ng mga molecules with odd electron central atom. Ang manggawas kay mga nitrogen oxides, example, nitrogen monoxide, nitrogen dioxide. Okay? And that is ang pinaka-reason ana, it is because these are they are usually called as free radicals. Okay, kung maingon ka og free radicals, these are species. Okay, this could be a molecule, this could be an ion that contain a lone electron. A lone lone electron or unpaired electron. Okay? So, nga na. Nakay makita nga bungkig ba? Okay? Sige, let's try to check, no? Let's try to check if meron ba talagang unpaired electron yung mga central atom na to in their specific molecule. So, let's start, for instance, with, nitrogen monoxide. So, ayon na pagkuan. Pag duha-duha kung kinsay central dira, iabay lang na sila. Kay duha raman na ka atoms, no? Walang subscript. So, katabi lang yan sila dalawa. Nitrogen, oxygen. So, pwede ra diretso ka buhat og single line. Tsaka ka mag-total. It depends on you, ha? Total. Okay? Total valence electron, nitrogen. Nitrogen monoxide. So, 6 plus 5. So, you have 11. No? So, you have 11 electrons. Nag-present na ako ng single bond. So, minus 2 electrons. So, you got 9. No? 9 electrons remaining. Okay? So, sa remaining, you distribute that by pair sa each. Okay? Hanggang ma-attain nila yung octet. So, let's start with the most electronegative. Okay? So, let's have With oxygen, much more electronegative man siya. So, kailangan siya ng 6. Okay? Kailangan niya ng 6 kasi kulang pa ng 6. Meron na siyang isang bond, so that is 2. Kulang ng 6 para maging 8. So, okay na si oxygen dyan. So, nakadistribute na tayo ng 6. From 9, minus 6 na na-distribute, so napay 3 remaining. Ayan. So, pag-distribute ng tatlong remaining, meron kang, tingnan, unpaired electron. Pero, na-distribute naman natin lahat. Obvious man, imuhang mabalaan diretso kung naagid ni siya ay unpaired electron upon distribution kasi yung mismong remaining electron is an odd number. Of course, you will really expect na upon distributing by pairs, meron talagang maiiwan na mag-isa. Okay? So, this would be one of the Lewis structure for nitrogen monoxide. Okay, we can have another structure actually ng nitrogen monoxide here. Diba? Instead nga, una ka mag-distribute sa oxygen, pwedeng mag-distribute ka muna kay nitrogen tsaka kay oxygen. So, okay lang din ganun. No? So, meaning meron siyang somehow resonance form. No? Another Lewis structure, pero of the same molecule. Diba? So, una tayo kay nitrogen, distribute mo yung 6 kasi kulang din siya ng 6. Meron na siyang isang bond, the same. Okay, so 8 na yan. Then, may remaining 3. So, pwede din ganito. Okay, yung Lewis structure niya. Okay, so yan yung example ng molecule na may odd electron atoms. Okay. You can actually check if sino, di ba sa resonance form, kapag nakapag-produce ka ng resonance forms, you can identify sino yung much more contributor sa resonance hybrid. How? By determining again the formal charge ulit. Di ba? So, bilang mo lang, yung technique ko is memorize mo lang yung valence electron niya, then bilangin mo lang lahat. Okay? Bilangin mo yung lone electrons, including the bond. So, you have 1, 2, 3, 4. So, di ba si nitrogen is 5, yung valence niya. So, minus 4 na ko diretso. So, that would be 1. Okay? Ay, hindi. 5 man yan. No? 1, 2, 3. Wait sa. Okay. Kadali lang. Okay. Wait sa ha. Pwede pa natin ma-attain yung stable state niya. Kasi si oxygen pala yung katabi niya. Diba si oxygen, meron siyang stable number of bonds. Pwede pa pala, oo. Wait sa ha. Sige, balik tayo kay nitrogen monoxide. Okay na yun. Okay na yung meron ng isa. Then, di ba, 6 yung na-distribute natin sa kanya. Then, ayan. Sige. Ayan. So, 9. Di ba, 9 electrons yung na-distribute natin. Nakalimutan ko kasi yung 5th rule. Di ba, hindi na-attain ni nitrogen dito, yung octet. Hindi niya na-attain. Although na-attain ni oxygen. Pero hindi na-attain ni nitrogen dito. Diba? Kasi ilan lang yan? 2, 2 sa isang bond, 3, 4, and 5. So, kulang siya ng 3 para maging octet. Kung gusto nyo talagang ma-attain niya yung octet niya. That's why, don't forget, although na-forget ko, don't forget the 5th step. Okay? Yung 5th step, wherein you change a lone pair from a surrounding, okay? Then, change that into a bonding pair. Okay? So, ana. So, you have a double bond here. Ayan. Okay? So, that would be the first structure. So, ganun din yung gawin mo sa kabila. Di ba, you already have a 6 electrons sa nitrogen, then you have 1 lone pair and 1 unpaired for the oxygen. Si oxygen dito, hindi di ba niya na-attain ulit? Yung octet, kulang din siya ng 1, 2, 3, 4. So, kulang siya ng 4. Okay? 4 ba? 2, 4, 5. Kulang siya ng 3. So, same lang. Same with nitrogen kasi dalawa yung electrons equivalent to this bond. So, 5. Okay, yung surrounding electrons ng oxygen dyan. Okay, so kulang siya ng 3. So, i-apply natin yung 5th step in writing Lewis structure. Okay, so yung surrounding, isa lang naman yung katabi niyang atom. So, gawin natin yung, ayan, bonding pair. Bonding pair. So, the same lang. The same lang ng structure 1, structure 2, nagkapalit lang yung location ng lone pairs, okay, or lone electrons, tsaka, yun lang, lone electrons lang yung nagkapalit, dalawa lang naman yung atom dyan. So, hindi nagkapalit yung bonding, di ba, bonding electrons. Kasi in between nitrogen and oxygen lang naman yung bonding electrons. Okay, sige, check natin yung formal charge ulit. Okay, balik tayo sa formal charge. For nitrogen, sabi ko, para mapadali na lang yung pag-compute nyo sa formal charge, di ba, ulitin natin yung formula niya ha, di ba, number of valence, electron of that atom, the number of lone electrons, or the unshared. Palehas lang yan. Si lone electrons, siya yung unshared. Plus the number of bonds. Okay? So, yung ginagawa ko, di ba, in the case of nitrogen, meron siyang lone electron na 3. Okay? So, binibilang ko siya kasama yung number of bonds agad. Okay, so, kasi plus man, i-add mo daw yung lone electron to that of the number bond. So, binibilang ko na lang siya agad. 1, 2, 3, 4, 5. So, 5 na dito. Then, di ba na-memorize? Di ba sabi ko, i-memorize nyo yung valence electron ng mga common atom. So, alam nyo na si nitrogen is 5 valence electron. So, minus 5. So, 0. Okay? So, ana lang. Or, you can have that way nga bilangin nyo yung number of ayan. So, number of bonds niya, you can also use that. Okay, example, in the case of oxygen. Diba si oxygen, yung pinaka most stable number of bonds niya is 2. Okay? So, kahit hindi mo nakunin yung formal charge niya, okay, stable binding na yan si oxygen. Meron na siyang dalawang bonds. So, 0 din. Or kahit i-compute mo, kung gusto din ninyo, i-compute ang formal charge, okay lang din. Okay? So, at that structure 1, di ba? Stable yung binding ng atoms in that molecule. Okay? Actually, much more stable yan. Knowing na 0 yung na-attain for both atoms. Sige, try natin yung isa. Okay? So, yung isa naman, di ba, you will get a formal charge here of a negative 1. Okay? Negative 1. Kasi bilang mo lilit, di ba, si nitrogen, 5 valence electron. So, you simply count. Okay? I-combine mo ba pag-count both the lone electron tsaka yung number of bonds. So, 1, 2, 3, 4, 5, 6. So, 5 minus 6, negative 1. Okay? Then, si oxygen dito, ganun din yung gawin nyo. Diba, oxygen has 6 valence electron. So, bilangin nyo lahat yung lone electrons niya dito. Okay? You have 1, 2, 3. The number of bonds, 4, 5. So, minus 5. 6 minus 5. So, you have positive 1. Okay? So, between the two structure, obviously, much more contributor sa resonance hybrid yung first structure dito. But although this is also a possible Lewis structure ng nitrogen monoxide. Okay? Sige. So, erase ko ha. Ayan. Then, the same with the molecule nitrogen dioxide. Okay? Ganun lang din yung mangyayari sa central atom na nitrogen. It will have a unpaired electron. Okay? So, sige, check natin ha. Ayan. So, let's have the first structure. Paano naging meron siyang unpaired, no? Or one lone pair. Walang partner. Sige. For the placement, no problem. Diba? Yung first step in writing Lewis structure is the placement. So, obviously, isa lang naman yung nitrogen, mole ng nitrogen dito, dalawa si oxygen. Si oxygen talaga yung nasa labas. And isa pa, lowest electronegative yung nitrogen. So, siya talaga yung nasa central atom. So, no problem. So, you draw a single bond muna, single bond to that of the surrounding oxygen. Total valence electron. Oxygen has 6 times 2, 12. Okay. Then, plus 5, 17. Okay, 17 electrons. So, from 17 electrons, minus ka ng, di ba, nag-provide ka na ng first 2 bonding. Okay, pair. So, that would be minus 4 electrons. So, you got 13 electrons na lang. So, ito, na-distribute na yung 13. 6 for this oxygen. Then, sa kabilang oxygen dayon. Kay, di ba, una tayo mag-distribute sa surrounding. Okay, surrounding atom muna. Okay, then 1, 2, 3, 4, 5, 6. So, 12, then 13. So, na-distribute yung 13. Ngayon, di ba, kapag ang central atom or yung adjacent atom, hindi niya na-attain yung octet, yung ginagawa natin, yung practice is apply the fifth step. Okay, kaya yung nangyari dito is from a surrounding from the surrounding atom na may lone pair, i-convert niya yon into a bonding pair. Kaya ganyan yung naging structure ng una. And you all know nga this particular structure, kapag ganito yung structure, di ba, may mga surrounding at hindi na-attain ng central atom yung octet, tapos may mga surrounding atom na the same, and the same, tapos the same pa yung number of lone electrons nila, this would probably produce another structure. Kaya meron siyang isa pang resonance form. Okay? So, imbis na, di ba, kanina dito siya bali, ito ba? Itong bonding pair na yan, di ba, galing yan sa lone pair. Okay? Lone pair na to. So, instead nga dito siya kumuha ng lone pair para gawing bonding pair, yung sa kabilang structure naman, ayan, sa kabilang structure dito naman siya kumuha. Okay, dito siya ayan. So, this particular lone pair, na-change siya into a bonding pair. So, ito na yun. Okay? So, the same lang yun. Okay, so that is how to convert one resonance form to another. Simply change the lone pair of the surrounding atom into a bonding pair. Okay? So, that's it for the odd electron atoms. Okay? Diba? Hindi pa rin yan ni-attain. Kahit na-drawn na natin yung mga Lewis structure nila, try to check the atom of nitrogen, and then in this example, si oxygen. Hindi yan 8, total of 8 electrons. Dito, 2, 4, 7 lang. No? Tagsi 7 lang sila. So, odd. Diba? Odd number yung 7. Or, yung mismong atom na yan, particularly the central atom. In the case of nitrogen dioxide, it has a lone electron or unshared electron. Okay. And another thing that you also need to know, no, basta gani free radicals, di ba naa sila'y unpaired electron. They have that characteristic nga reactive, as in highly reactive sila. Okay? Meaning, they really need to interact, undergo. Ngano 13 ang nabilin? Ansa to? Ito, Mr. Sa Cantarona. 13. 13 kasi di ba from the total number of bakit daw 13 yung natira remaining? Di ba you first total the valence electron 6. The valence electron for oxygen is 6 times 2. So 12 plus 5. 12 plus 5 is 17. And then, di ba, you already, ang first step yun nato, di ba, is one line muna, one bonding. A single bond muna to connect the central to the surrounding. So this is a total of 4 yung na-present natin. So minus 4, 17 minus 4, 13. Okay, 13 remaining electrons. So upon distributing, so tag-aanim, ngayon yung surrounding atom ng oxygen, so 6, 12, then 13. So yan yung initial na structure mo. Pero 'di ba in writing Lewis structure, you have to check dayon the surrounding and the central if na-attain da nila yung octet. Na since in nitrogen hindi man yan na-attain yung octet. So yun na yung pag-apply ng fifth step. Okay, so that is why meron ng multiple bond kasi in-apply na yung fifth step. Nag-change tayo ng lone pair from the surrounding into a bonding pair. Sige. So, dito tayo kay free radicals. Okay. Please take note na highly reactive sila. Di ba, pag sinabing highly reactive, kailangan talaga nilang mag-undergo ng chemical reaction. Bakit? Bakit kailangan? Kasi para maging stable sila. Okay? They are highly reactive to the point nga gusto nilang maging stable. Okay? To attain stability. Okay, yan yung purpose. That is why kahit may unpaired, meron silang tig-unpaired no nga electron, they can still attain the octet for that particular central atom. How? By interacting two molecules of that particular radical. Say for example, sige mag-erase ko ha. Say for example, ito, in the case of nitrogen dioxide. Diba, you have that, ayan, nitrogen. Diba, meron siyang isang unpaired. I-change ko lang yung arrangement ha, but it's still the same. Yeah, again ha, meron kayong nitrogen, then unpaired. So, ito lang yon, nitrogen, unpaired, then may double bond towards isang oxygen. Then yung oxygen na yon na may double bond towards nitrogen, 4 na lang. Okay, then meron siyang single bond towards another oxygen, then meron yang 6. No? Parehas lang yan ha. Ano lang yung pagka-orientation ko ng placement. So kahit magkaiba tayo sa correct answers ko, magkaiba tayo ng positioning placement ng atoms. Kung tama yung number of bonds, number of electrons, tama yung central atom, tama yung surrounding, tama yung sagot nyo. Diba, kanya-kanya man tayo ng style sa placement. Basta as long as the same, yung bonding number, distribution ng electrons, correct yung structure nyo. Sige. Sabi ko, free radicals, they can still attain, free radicals particularly yung central atom nila, no? They can still attain the octet. No? How? Since highly reactive sila, they will react with each other. No, free radicals will react with each other to pair up their lone electrons. So you have another lugar, another nitrogen dioxide. So pwede yan sila mag-react. Okay, so another lang ni siya ha nga ing ani. Okay, the same lang akong idro, lahi lang ang ilang orientation. Okay, parehas lang yan. Okay, so both of them have the central atom nitrogen na may unpaired, no, unpaired electron. Okay, so upon reacting that two molecules, the lone electron will now pair up. No, the lone electrons will now pair up to form a bond. And that is an example of a covalent bond. Okay, so that is how usually free radicals attain their octet, no? Ayan. So, Ana. So that is the reason highly reactive talaga yung mga free radicals kasi gusto talaga nilang ma-attain yung stable state nila. Okay, so normally free radicals, they will react with each other just to pair up lang good. Kasi 'di ba meron silang unpaired, so yung gagawin nila, mag-share na lang sila ng electrons. Kapag may sharing of electrons, 'di ba, that is a form of a bond. That is a covalent bond. Okay? So, yan yung nangyayari for free radicals. Okay? So, we are done with the first two important exceptions. Yung kanina ulit is yung electron-deficient, no? Meaning lower than 8 yung surrounding electrons of the central atom. Kapag sinabing odd electron atoms, meron kang a central atom or an adjacent atom na may unpaired electron or a lone electron. Walang partner ba? Okay? Sige, let's have the last, no? So, last exception. Yung exceptions to the rule, octet rule in writing Lewis structure, it occurs naman to molecules with expanded valence shells. Okay. Now, basically, there are a lot, no? There are many molecules which have more than 8 electrons. So, this is actually the opposite of letter A nga exception. Kung sa letter A, electron deficient, so lower than 8, ito naman, sumobra ng 8. Kasi nga, yung atom na yan, meron siyang capability nga i-expand yung valence shell niya. Okay? And usually, nag-expand siya ng valence shell just to form more bonds. Now, ano ba yung criteria ng isang atom para capable siya mag-expand ng valence shell? Of course, that central atom must be large. No? Dapat it has to be large and large yung size niya ba? Di ba? Pag sinabing larger yung size ng isang atom, example, this is an atom, larger yung size niya, that also means nga meron siyang maraming shells. Okay? Meron siyang maraming orbitals pa. Diba? In an orbital, doon natin makikita yung electrons. Okay? Another thing is, meron siyang, knowing large yung size niya, that would also mean na naapod siya empty orbitals na kaya ding mag-hold ng additional pa na pair of electrons. Okay? Particularly, ang mga expanded valence shell, this occurs among non-metals. Non-metals nga makikita sa period 3 ng periodic table. Okay, tingnan natin ha, nato dere. Okay, tingnan natin yung periodic table. Ayan. Okay. So, ito. Diba, you have a periodic table here. Ayan. Yung mga atoms na usually commonly nag-e-expand ng valence shell na capable sila na mag-hold ng more than 8 electrons. Usually mga non-metals yan from period 3. Again, non-metals from period 3. Example, phosphorus, sulfur, chlorine, and so forth. Iodine, xenon, ayan. Ito yung pinaka-common na nag-e-expand talaga ng valence shells. Okay, sige. Para mas maintindihan, okay, try natin i-recall yung filling up electrons in an orbital. So, sige, let's try to extract one. Example si example si, kadali ha, ayan. Okay. Example, phosphorus. Okay. Si phosphorus, di ba, it has 15. Nasa 15 nga atomic number, and recall nga atomic number that is equivalent to proton number, and for a neutral atom, equivalent lang yung proton number sa number of electrons. Therefore, 15 yung i-distribute natin na electron sa orbitals ng phosphorus. Okay, diba? So 1s first, 2s, 2p, then 3s, 3p, then hanggang dyan na lang. 1, 2, 3, 1, 2, 3, 3 orbitals sa p sublevel. Sige, fill up natin yung 15. Diba? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay? Pero take note na 'di ba pagdating sa third shell, meron na tayong 3D which has 5 orbitals. 'Di ba ang D sublevel merong yang 5 orbitals. Sige ha, nadumduman ang order pattern. Yung pattern na dapat yung i-memorize. Diba? Sabi ko, pattern lang, 1, 2, 3, then 2, 3, 4, then 3. And so forth. So forth na siya, so forth. Diba? Dito P, dito D. Pagdating sa third shell, diba meron ng D orbital? Now, in the case of phosphorus, hanggang P lang siya nag-fill in. Therefore, kumbaga meron siyang empty. Okay, meron siyang empty ba? Empty nga valence shell. Okay, meron siyang empty orbitals na pwedeng hold, pwedeng mag-hold ng additional pairs of electrons. Kaya si phosphorus capable talaga siya mag-expand. Kasi large siya na molecule, meron siyang empty orbital. Okay, so ang criteria talaga for those central atom na pwedeng mag-expand pwedeng mag-hold ng more than 8 electrons is yung mga atoms, usually from period 3 and baba. Okay, hindi naman lahat, pero pinaka-common to, kanang akong mga gipang circulan, phosphorus, sulfur, yan, chlorine, okay, xenon, iodine, minsan si bromine, ayan. Okay, so those are the most common. Okay, kasi meron silang empty orbital. Pwede nga makapag-hold ba ng additional pair of electrons. Sige. Sige, let's have an example. Say for example, ayan. Si example, ang given is phosphorus. Ayan muna. Phosphorus trichloride muna. Ayan. Kung i-draw ninyo ang Lewis structure ni phosphorus trichloride, ito yung magiging result. But, wait wala pa siya nag-expand in this case. Wala pa na-expand si phosphorus in particular. Okay? Kasi 'di ba si phosphorus yung capable mag. By the way sa mga exception to the rule, ang atong ginapasabot ani is si central atom. Okay, ang mga central atom mula electron-deficient atom, si central atom yung pinupunto natin dito. Hanggang odd electron, hanggang dito expanded valence shell, si central atom. Tingnan, si phosphorus, 'Di ba? 8 lang yung surrounding electrons. So, hindi pa yan nag-expand. Okay? Kasi yung given lang is phosphorus, trichloride. Okay? So, okay lang to na-attain niya yung octet. Okay? So, di na ako balikon ha nga nung ingana ang Lewis structure. The same lang. Okay? Placement of phosphorus, siya yung central, surrounding yung tatlong chlorine. Then, total number of valence electron. Then, minus the 3. Okay? Ito, 3 single bonds from the total. Then, yung remaining, i-distribute nyo. Okay? So, ito yung magiging result ng Lewis structure for phosphorus trichloride. And okay naman na-attain niya yung octet. It has an octet. Yung phosphorus has an octet. Phosphorus trichloride ba? Dito. Okay? Yung phosphorus sa phosphorus trichloride, it has attained the octet. Now, paano naman kapag nag-react yan sa dalawang moles ng chlorine, particularly chlorine gas. Diba? That is a chlorine gas. Diba? Kung imong i-draw ang Lewis structure ng chlorine gas, that would be the structure of chlorine gas. Okay? Of course, upon interacting, this bond will break. Kapag na-break yan, tag-iisa sila ng unpaired. Tag-iisa sila ng unpaired electron. So, parang ganito yung mangyayari. You have chlorine with unpaired. Then you have another chlorine na unpaired. Kasi kailangan mag-react with phosphorus trichloride. So, may unpaired. Now, recall na si phosphorus, tingnan nyo yung central atom na phosphorus. Di ba meron siyang dalawang dalawang lone electrons. Okay? Meron siyang isang lone pair. Okay? Another way to describe that electron. Pwedeng isang lone pair or dalawang lone electrons. Okay? So, since meron siyang dalawa, so pwede niya yan i-share. Diba? Share niya to sa isang chlorine na may unpaired. Then, meron ding isang chlorine. Diba? Merong unpaired yung tig-isang chlorine para ma-attain ng chlorine na to yung stability upon interacting with phosphorus trichloride. Now, in this case, kung titingnan mo yung number of valences, not valences, I'm sorry for the term ha, it's not valences, number of surrounding electron. Tingnan, bilangin nyo nung number ng number of surrounding electrons ng phosphorus, di ba? That is not already 8. Okay, that is total of 10 electrons na. Kay 5 bonds mo yan, di ba? Per bond equivalent to 2 electrons. So, 5 bond times 2, so total of 10. So, nag-expand yung valence shell ni phosphorus dyan. Okay, that is why, ayan. Ito yung structure ng phosphorus pentachloride. Okay? Again, ito yung structure ng phosphorus pentachloride. Parehas lang to ha. Parehas lang yan. So, ako lang i-erase niya siya. Okay? So, ayan. Okay? Diba? 10 electrons na yan. 10 electrons. Yung surrounding electrons ni phosphorus. So, capable naman, okay lang naman kasi capable si phosphorus expand. Okay? Kahit i-check nyo yung i-check nyo yung iyahang formal charge para malaman nyo kung at stable binding ba siya. Okay? You can also attain a 0 formal charges for each. Diba, ang mga halogens, isa lang yung bonds, pinaka-most stable na nila yan. Okay, so for chlorine, lahat ng surrounding chlorine, 0 yung formal charge. Si phosphorus, formal charge ni phosphorus, diba, phosphorus, hanap na lang. Phosphorus, formal charge. Diba? Yung valence electron ni phosphorus is 5. Huwag kalimutan ha, yung formula ng formal charge. Formal charge. Valence electron minus number of lone electrons or unshared, wala. Plus bonds, 5. So, 0. Okay? So, stable yung binding niya kahit nag-expand siya ng valence shell. Okay? So, yan yung isa sa example natin na molecule na may central atom na nag-expand. Okay? Yung valence siya. Sige, these are other examples. Okay? So, these are other examples. So, kung you try to draw their Lewis structures mula following the basic steps, ito yung magiging result ng structures nila, Lewis structures. Okay? Ayan. So, nag-expand sila lahat, diba? Sige, start tayo kay sulfur hexa, diba? Sulfur hexa fluoride. Okay? So, obviously, si sulfur yung magiging central dyan. Diba? Fluorine as a halogen, diba? Fluorine. Si fluorine as the most electronegative atom, it will never be a central atom. Diba? As based on the rule, lowest electronegative atom, okay, or least electronegative atom, sila yung dapat central. So, 6 daw. So, you form 6 bonds connecting sulfur to that fluorine each. So, kana pa lang daan, 6 bonds na imong na-form. Pila man na ka-total electrons kung 6 bonds? Diba? That is a total of 12 electrons kung 6 bonds. So, 6 times 2. 12 electrons. So, nag-expand. No? Kung i-total nimo na ilahang valence electrons, okay? Ayan. Times 6. Then, 6 ba? 6 also. Yung kay sulfur dyan. Okay? Ayan. So, you will, 42 yung magiging remaining. So, i-distribute mo yan. Tiga-6 sila. Okay? So, that would be the Lewis structure for sulfur hexafluoride. So, nag-expand. Ganon din kay iodine. Diba? Iodine. Ayan. Okay? So, Lewis structure lang yan. Pwede, ma'am, nga iba yung structure namin. Oh, okay lang. Basta 5 yung bonds. Okay, 5 yung bonds connecting iodine to fluorine. Tapos, meron siyang isang lone electron. Ay, isang lone pair. Isang lone pair. Dalawang lone electrons. Okay? Following rani siya ha, following the basic steps in writing Lewis structure. Then upon checking, after you write their Lewis structure, pag chinek nyo yung central atom nila, nag-expand yung valence shell most probably nila. Kasi more than 8 yung surrounding electrons nila, di ba? 2, 4, 6, 8, 10, 11, 12 ulit. No? 12 electrons ulit sa central atom na iodine. Okay, so the same with xenon. Okay, pero kung kunin mo yung formal charge nila, okay, 0. Okay, 0 yung mga formal charges nila. So at its stable binding yan sila. Okay. Okay, so the same with the last example, xenon tetrafluoride. Okay, you will also get a formal charge for each atom, 0. So stable yan sila lahat kahit yung central atom yung central atom has more than 8 electrons around them. Okay. Sige. Other example. Sige, dito tayo kay sulfuric. Okay? Sulfuric acid. Okay? So, obviously, si sulfur yung magiging central atom dito. Kasi between sulfur and oxygen, less electronegative si sulfur. Okay? So, Ayan. So, sulfur as the central atom. Sige, atong tagsa-tagsahon na. Then, diba si hydrogen, it can never be a central atom. So, unahin natin yung placement ni oxygen dito. Okay, unahin natin yung placement ng oxygen. So, it has, ayan, oxygen, ayan. Okay. Then, for hydrogen, merong dalawang hydrogen. Saan natin ilalagay yung dalawang hydrogen? Basic knowledge lang, di ba? We all know nga ang oxygen can have a stable number of bonds na 2. So, pwedeng may dalawang oxygen dyan that carries or being bonded to a hydrogen. Okay, so most probably this would be the placement, okay, of the atoms sa molecule na sulfuric acid. Sige. Kunin natin yung total valences nila. So, oxygen, 6 times 4. Okay. 6 times 4. 6 ba yung, tama, 6 yung kay oxygen. Then, si sulfur, parehas lang sila ng group ni oxygen, 6 din. Okay. Then, we also have hydrogen, which is 1. Okay. Sige, ilan lahat yung total valence? 32. Okay, very good. Okay, 32 electrons. Tapos, minus ka ng 6. 6 ba yan? 1, 2, 3, 4, 5, 6. Total of bond, so 12. Okay, tama ba? 12. Okay, very good. 20 electrons. Okay, so itong 20 electrons na to, distribute mo yan, okay, individually sa surrounding atom. So you start, of course, sa oxygen na isa lang yung bond. Okay, so 12 na yung na-distribute. Okay, so kulang pa. Ayan, distribute mo yung remaining sa, ayan, sa inside, yung another central na oxygen. Okay, so 20 na lahat. Tama ba? 12 plus 6, 20 yung na-distribute na electron. So, okay na. Ngayon, kung i-try nyo i-check yung formal charges nila, you will actually produce several non-zero na mga formal charge if ito yung magiging final answer nyo for the Lewis structure ng sulfuric acid. Okay? Sige. Try natin i-check ha yung formal charges nila. Okay. So, for hydrogen, okay na, 0. Okay? Yung oxygen dito, most probably 0 kasi meron silang dalawang bonds. Okay? What about these oxygen sa outside? Diba? Positive 1 ba? Or negative 1? 7, negative 1. Okay? So, magkakaroon siya dito ng formal charge na negative 1. Ayaw ma-erase. Oh, wait ha. Ayan. Ayan. Okay. So, negative 1. So, ganun din sa baba. Negative 1 din yung formal charge nito. Ano lang ha yung formula sa formal charge. Diba, valence electron ng oxygen is 6. Okay. Then, number of lone electrons, then plus the number of bonds. So, 7. So, negative 1. Okay. So, negative 1. Dito, 4 lang yung bond. So, positive 2. Okay, yung magiging charge ng central atoms. Di ba? Kung titingnan nyo, na-attain nga na-attain ni sulfur yung octet. Diba? Na-attain niya yung octet, 4 na bonds, equivalent to 8 surrounding electrons. Na-attain nga niya yung octet, pero it has several non-zero. Okay, non-zero na formal charges. And remember, sa criteria natin in determining a stable bonding ng atoms in a molecule, yung several non-zero formal charges, di ba, it is not preferable. That is why, in this case, si sulfur needs to expand its valence shell. Okay, so yung mangyayari ngayon, ayan. Sorry. Ayan. Okay, balik ko si sulfur. Di ba si sulfur, as mentioned earlier, present siya sa periodic table under period 3. And I have mentioned earlier nga yung mga atoms found in period 3 and pababa, sila yung mga atoms na usually nag-e-expand. So si sulfur, capable din siya mag-expand. So i-apply nyo lang yung 5th step in writing Lewis structure. So mula sa surrounding electron alone, na-erase. Okay. Ayan. So mula sa surrounding atom, di ba, it has a lone electron for this oxygen. Ayan. So change mo yan into a bond. Ayan. Into a bonding pair of electrons. Okay. So ganun din dito. Ayan. Okay. Syempre hindi ka kukuha, na-erase naman din ang uban. Ayan. Okay, syempre hindi ka kukuha dito sa oxygen na to kasi these are not surrounding. Diba? These are also central. Ito yung mga central atom. Diba? Ang surrounding, yung pinaka nasa labas talaga. Okay, so obviously ito. Ito. Si hydrogen, of course, wala naman siyang, never man yan magkakaroon ng lone pair or lone electron si hydrogen. So, dito ka lang kumuha. Okay, yung lone electrons ng dalawang surrounding oxygen na yan, change mo yung tig-isang pair, lone pair nila into a bonding pair. Okay, ayan. So, in this case, si sulfur as a central atom, di ba, nag-expand siya. Particularly, ilan yung number of surrounding electrons niya? Diba? 12 electrons. Tama ba? 2, 4, so 6 bonds. So, merong 12 electrons. Okay, so nag-expand siya. Okay, so the same with phosphate. No? Phosphate ion. Okay, so si phosphorus, di ba kanina sa example na phosphorus pentachloride, yung earlier na slide, si phosphorus nakapag-expand siya, having 10 surrounding electrons. So in this case, si phosphorus sa phosphate ion, capable din siya mag-expand. Sige, tingnan natin ha. So 4 na oxygen sa surrounding. Ayan. Okay? So, okay na yung placement ng atoms. Okay, let's proceed to the total valence electrons. So, you have 6 for oxygen. Okay? So, 6 for oxygen, then for phosphorus. Tama ba? 5 yung phosphorus. Okay. Same lang man sila, diba? Ni nitrogen. Okay. So, the total would be ilan ba? 29 electrons plus meron pang charge na 3, 32, no? So total of 32 electrons. 32, ayan, electrons. Okay, total pa lang to ha, total valence electron. Okay, so pag may charge ha, yung polyatomic ion given, please give importance gud sa ilahang charges kay mag-matter gud ilahang total valence electron. Okay, so from 32 minus pa yan sa apat na single bonds na presented already. Okay, so from 32 minus ka ng 2, 4, 6, 8. So that will give you, okay, 24 electrons. Okay. So okay, very good. Okay, so 24 electrons. So from this, 24, distribute mo yan singly for each oxygen. 24. Ayan. Okay, so ubos na yung remaining electrons. Now, if this would be your Lewis structure, again, kung inyuhang kwaon iyahang formal charges for each atom, you will produce several non-zero na formal charges. Okay? That is why you really have to let that phosphorus expand its shell. Okay, so pwede more than 8 yahang surrounding electrons. Ay, sorry. Okay, so ana na lang. So ayan, so that would be the structure for phosphate ion. Okay, so erase ko ha. Sige. Ayan. So, gi-apply lang niya ang 5th step. Diba? Mula dito na lone pair. Okay, gi-change niya ang isa into a bonding pair. Para si phosphorus ngayon will now attain a much more stable na binding towards its surrounding atom. Okay? So, 0 charge for phosphorus, 0 charge for the bottom oxygen. Then, syempre, no choice tayo. Kailangan meron talagang charges, formal charges, yung the rest na 3 surrounding atoms na oxygen for phosphate. Kasi, di ba, para malaman natin nga yung buong molecule na yan, yung atom sa buong molecule na yan is at its stable binding, dapat yung totality ng formal charge nila will equal to the charge ng species. Diba? And the given species, diba, is a polyatomic ion. Therefore, kung ano yung charge ng ion na yan, dapat yan din yung total formal charges buo in the whole molecule. So, negative, tatlong negative equivalent to negative 3. Okay, which is equivalent to the charge of that species given. Okay, so that would be the most stable structure, Lewis structure for the polyatomic ion phosphate. Okay, sige. Okay, let's have the following other examples pa. Sige, let's start with phosphoric acid. Okay, so sabi dito, draw the Lewis structure. Identify the octet rule exception. Okay, so Lewis structure, identify the octet rule exception. If identify the octet rule exception, it's either ang central atom electron-deficient, odd-electron, or valence, nagkaroon ng expanded valence shell yung atom na yan. Sige. So let's start with sample 1. Okay. So, for the phosphoric acid, ang central atom would be phosphorus. Okay. Si phosphorus, meron daw siyang apat na surrounding. Ayan. Apat na surrounding oxygen. Okay. Ayan. And then, you have also another surrounding hydrogen. Okay. So, merong tatlong oxygen that is directly bonded to a hydrogen. Okay. Okay, yung next, total. Sige, total nyo yung valence electron. You have oxygen 6. Okay. So, 6 times 4, 24. Tama ba? 6, 12, 18, 24. Okay, then for phosphorus, plus 5. Then plus 3. Ilan ba? 32 ba? Okay, 32 electrons. So you start, very good, start distributing that remaining 32 electrons sa first surrounding nga atom. So yung nasa taas, 'di ba? Ang surrounding lang man natin, pinaka-surrounding talaga is isang oxygen, then hydrogen, hydrogens. Okay? Sige. So, 1, 2, 3, 4, 5, 6. Okay? Then, ay, wait ha, hindi pa 32. Total pa man eh. Diba? Minus pa. Minus, ilan ba to? 2, 4, 6, 8, 10, 12, 14. So, minus 14, that would be 18 ba? Okay, 18 electrons. Okay? So, ayan. So, distribute natin yung 18. So, 6 sa taas, 4 sa magkabilaan ng mga oxygen. Okay? So, total of 18 already. Okay? Tama, 18 na yung na-distribute natin. Now, if ito lang yung sagot nyo for the Lewis structure ng phosphoric acid, mali pa to. No? Kaya again, kung kukunin nyo yung formal charges, okay, di ba? Formal charge dito would be negative 1. Dito, this would be positive 1. Okay? Okay lang dito, 0, 0, 0. Diba? Kung imuhang, ang tao, naa kay mga charges for oxygen na surrounding atom and the central atom na phosphorus, meron siyang formal charge na positive 1. Now, meron pa itong actually much more stable na binding, yung phosphorus na to as the central at saka yung oxygen na to. Diba? We all know nga si phosphorus, capable siya of expanding. Therefore, we can change one lone pair, ayan, one lone pair from that, diba, from 6, change natin yung one lone pair na yan into a bonding pair towards phosphorus. Okay? Para ma-attain nila ngayon yung pinaka-stable bond. So this time, wala na silang charges. So ito yung pinaka-most stable bonding, okay, binding ng mga atoms in that molecule of phosphoric acid. Okay? Sige, let's proceed naman to, so okay na to ha, si phosphoric acid. Okay, sige. Let's have the other one. I-erase ko. Okay, number 2. Okay, boron fluoro dichloride. Okay. So, dito naman, kinsa karon ang magiging central. Sige, analyze natin. You have boron, then halogens. And we all know halogens are found on the right side ng periodic table. They are non-metals. Okay, and as a non-metal, somehow they have that high electronegativity property. So, sabi natin sa first step in writing Lewis structure, dapat lowest. Diba? Electronegative atom will come as the center. Okay, central atom. So in this case, okay, boron as the central atom. Okay, very good, Kenna. So meaning, itong isang fluorine na to, dalawang chlorine, surrounding atom yan ni boron. Okay? So, anywhere you want. Okay? Asa ninyo ibutang si fluorine? Asa ibutang si chlorine? So, depende yan sa inyo, ha? Sige. So, let's say for instance, chlorine dito. Then, you have fluorine sa baba. Okay? So, pwede yan. Pwede po, naipangapaslanting-slanting. Pwede ra po ding ana. So, it's up to you, ha? Parehas na sila. Okay? Same lang. Basta sakto ang central, sakto ang surrounding, sakto ang number of bonds. Sige. Total. Okay? Total valence electron tayo. Sige. So, you have 3 halogens na, diba? Halogen, halogen, halogen. So, 7 times 3. 7 man ang halogens. 21. Plus 2. Plus 2 ba? Si boron, plus 3. Diba? Si boron is 3. So, 24. Okay? 24 electrons. Again, ha, si boron, part ng group 3. So, plus. So, it has a 3 valence electron. So, 24 minus 6. Sige, minus 6, 18. Tama ba? Okay, 18 electrons. Okay, very good. So, yung 18, distribute natin. Okay, distribute natin sa halogens, tiga-anim sila. Tiga-anim, anim. So, ubos na yung 18. Check natin si boron. Check natin si boron. Hindi niya na-attain yung octet, pero anong klaseng exception to the rule yan sa octet? Diba? That is electron-deficient. Okay? Yung kanina, expanded valence electron. Yung pangalawa, electron-deficient atom. Okay? Sige. Let's have the third one. Sige. Last slide na to actually, be. Oo, last slide. Sige. Let's have the chlorite. Okay? Chlorite. Kasi kapag 3 to, diba? Chlorate yon. Sige. So, minus 1 oxygen, chlorite. Sige. So, obviously, yung central atom dito would be chlorine. Okay? Sorry. Ayan. So, you have chlorine as the central atom, oxygen as the surrounding atom. And take note, it is an ion. So, enclose that in a bracket, square bracket. Sige, total valence electron. 7, di ba? 7 for chlorine times plus 12. Tama ba? Sige, ilan? 19. Tama ba? 19. I-kuhan ko ninyo ha. I-correct ba ako ninyo kung wrong. So, 19 electrons. Tapos, may charge na negative 1. So, plus 1. Okay? Okay, plus 1 electrons. So, 20 electrons. From that, 20 minus pa. Ayaw mo kalimot og minus ha. Minus the single bonds. Okay, total of 4 electrons. So, 16 electrons. So, distribute natin yung 16. Starting with either. Parehas lang naman yung surrounding. Taga-anim. Okay, 6, 12. Then, 13, 14, 15, and 16. Okay? Now, kung ito yung magiging final sagot nyo for its Lewis structure, malito. Okay? Paano nyo masasabi na mali? Kunin nyo yung formal charge, ha? Formal charge. Okay? Particularly in this case, magiging formal charge nila, 'di ba? Yung oxygen dito would be ilan man, negative 1. Diba? Dito din, negative 1. Okay? What about chlorine dito? 1, 2, 3, 4, 5, and 6. Positive 1. Okay? Ayan. Diba? Puros may charge. Okay? Puros may charge yung mga atoms in that molecule. And that is not preferable for a Lewis structure. Diba? And so inyo i-recall, si chlorine. Isa siyang atom na pwedeng mag-expand yung valence shell. Okay? So, try natin i-expand yung shell niya. Kung maka-attain ba taog medyo konting non-zero. I mean, konting zero nga mga formal charges. Sige. So, mula surrounding atoms na oxygens, kuha siya ng lone pair. Okay? So, either lang. Okay? Depende sa inyo, ha? So, pwedeng itong lone pair na to, gawin niyang, ayan, bonding pair. Sige, check natin ulit yung valence. Okay? Check natin ulit yung valence. Siyempre, ang ma-change lang ang valence is kaning duha. Kaya diri raman ta nag-change. Wala man nato gi-change ang isa. So, as is yung negative 1 dyan. Diba? Sige, check nyo yung valence. Si oxygen dito, meron siyang dalawang bonds. So, obviously, 0 yan. Okay, stable na siya ba? 0 yung walang formal charge, kumbaga. Sige, si chlorine, diba? 7 yung valence electron niya. Sige, bilangin niyo yung lone electron. 4. Okay, combine niyo sa number of bonds. 4, 5, 6, 7. Okay, minus 7, 0. Alright? So, kung i-compare mo kanina na structure versus ngayon na structure, this would be a much more preferable na mga formal charges for the atoms in this molecule. So, ito yung magiging best structure, Lewis structure for chlorite ion. Okay? So, okay lang na may negative 1 na being carried by isang atom sa molecule na yan. Kasi diba, take note, dapat yung magiging total ng formal charge, all in all, totality ng buo, total mo, lahat ng to na formal charges, dapat equal yan sa species na given. Species. Okay? Given. And a given is a polyatomic ion which has a charge of negative 1. So, tama. Okay, negative 1. Sige, so okay na tayo sa number 4. Okay, sige. Dito tayo sa, okay, number 5, last. Okay, number 5, last. Sige. Central atom, placement of the central atom. So you have phosphorus. Okay. Phosphorus has 2 surrounding atom. Okay. Total valence electron. Okay. 5 for phosphorus. So that would be ilan man? 17. Tama ba? 12. Oh, okay, very good. 12 plus 5, so 17 electrons minus 2. Okay, 2 na single bonds. So total of 4 yan, total of 4 electrons. So you got 13 electrons. So from this alone, may hint ka na kung anong klaseng octet rule exception yan. Okay, sige, check natin. So we have 13, distribute natin, ayan, tig-6 plus 13. And then, try pa natin nga ipa-attain talaga kay phosphorus yung octet. So, apply the 5th rule, change one of the lone pair from the surrounding into a bonding pair. Okay? Or the other way around, so yung isang structure niya, pwedeng dito naman yung double bond. Okay? So, 4 na lang. Dito yung single bond, 6. Okay? Ayan. Or kung gusto nyo pa talagang, ano yun, ipa-expand si phosphorus, pwede din naman. Okay? Pero ganun pa rin, no? Ganun pa rin. It will still have an odd na electron, no? Sa iyahang central atom. Okay? So, example, ganyan. So, okay lang naman. Okay? Meron siyang 11. At 11 ba yan? 2, 4, 6, 8, 9 radii. Okay? So, 9 na surrounding electron. So, odd pa rin yun. Okay? So, pwede din. Okay? Which is the most stable one. Pero, again, di ba, hindi niya na-attain yung octet. Okay? So, pwede ba yan na expanded valence shell? Yes, pwede din. Pero the best answer for this would be odd. Okay? Kasi obvious kaayo na meron siyang isang unpaired electron. Okay? Kasi usually kapag nag-expand yung valence shell, dapat may partner pa rin, no? Walang odd. Walang odd. Walang, ano yan, unpaired kumbaga. Okay, dapat lahat may partner kapag nag-expand yan. Okay, so for this example, pwede siya isang odd electron atom for its octet rule exception. Okay, so the same with nitrogen. Kasi di ba grupo lang naman sila. They are found in group 5. Ayan, group 5A elements. Si nitrogen, phosphorus. Okay. So, ayan. Sige, do you have any questions? Wala? Sure? Okay. If wala nang tanong, sige, proceed tayo sa, wait.